So I purposely wanted to leave this mark in here so you could see this, because I think it's going to be hard to see otherwise. So let's look at this. This is negative 2.27 right here. See it? And I left it really long, even though normally we wouldn't do that, because I wanted you to see where it was. Because the area to the left of it, it's there, but it's really, really tiny, right? Really, really small. I don't know if I can zoom in. Let me see. There's a little bit of line there, but it's not much, okay? And then over here, I've got 1.42, and I've got the area to the right of that, right there, okay? So what I want to do is I want to find each of those areas, and then I can add them up. That's one of the ways you can go with this. So let's find the area to the left of negative 2.27. Oops, if you type it correctly. All right, that would be equal to norm dist or norm dot dist, either one. Norm dot dist only, the dot part only exists in 2010 for Excel. Negative 2.27, comma 0, comma 1, comma true. There we go. So that tiny itty bitty area is 0.0116 and change. Then I want the area to the right of 1.42. Well, remember, areas to the right, we're going to need to do 1 minus norm dist. The reason you have to do the 1 minus is because norm dist does left tail areas by default. So you have to do the complement rule in order to get to the right tail area. Right? So if it was just the left tail area, if it was all this white stuff and that tail together, I would just do regular norm dist. But since I'm doing the right tail area, I want 1 minus norm dist. Okay, now I want together. Together, that gives me the area in the two tails put together. And those are what those are called on the edges, the tails. So that would be equal to the sum of these two numbers I found here. And there's a couple other ways you could do it. I probably show another way in the Excel tutorial video, but that'll suffice. So up here I can say 0.0. Oops, I can create a new worksheet. I don't mean that at all. All right, 0.0894, 4 decimal places. All right, so you know what's coming, right? Let's look here. So if you look at this particular page, what I was doing was I was having you find areas / probabilities, because when you're finding an area of a probability underneath a probability norm, probability distribution function like this, you're really finding the probabilities, right? Because it's a probability distribution. Probabilities in the name. All right, but I gave you z-scores for every one of these problems. Look at this. I'm giving you z, z, z. So you know what's going to happen, right? You're going to have to go in reverse. So here I'm giving you an area, 12%, and I want to know what the z-score is for it. I don't say that, but that's what I mean. So I already drew it down here for you. This is 12% right here. I mean, remember, 50% would be the median, right? That'd be like shading half the curve. So 12%, and I want to know the percentile. That's where this little bar comes down, right? That vertical line. All right, well, how do you do that? Well, you can use Excel. You don't want to do that by hand. So you want to say, okay, 0.12, here, 12% to the left of what z-score? Right, that's what I'm asking for. All right, well, that would be equal to norm. Okay, for me, you can use .inv, .inv. Technically, you can use .s.inv, or you could use norm inverse or norm S inverse, whatever. I mean, I think it's easiest just to know one way. So let's just do norm inv, N-O-R-M-I-N-V. Of course, for my purposes, it's .inv, but it works the same way as the old function. The probability is 0.12. The mean is 0. The standard deviation is 1. There you go. That's your z-score right there. Okay, so it's negative 1.17. They like 2 decimal places apparently right now. Sometimes they'll want 3, which would be 1.175. All right, we found the 12th percentile. That, see, notice it's just a little bit past negative 1. Negative 1.175 is where it hits the x-axis. All right, I'll be here for the next problem next time.